So what is relative motion? If you're in a car going 60 miles per hour, right? 60 miles per hour is really relative to the Earth. If there's another car that passes you at 90 miles per hour, but if you say, well, how fast is our car going relative to me that I'm going 60 miles per hour, it might seem reasonable that that car is going at 30 miles per hour relative to my car. That's what we mean by relative motion. And this formula here is a vector equation that kind of relates three relative velocities. And the way you can read this, you could say the velocity of A with respect to C is equal to the velocity of A with respect to B plus the velocity of B with respect to C. And so like if C, for example, represented the Earth, I could say, hey, maybe if car A is going at 90 miles per hour, this would represent 90, right? But if car A is going at 30 relative to B, then this would represent the 30. If car B is going at 60 relative to the Earth, this would represent 60. So 30 plus 60 would give you 90, kind of following the example I said earlier. How can we relate, though, what I just said? Like, how do we know that this formula is true? Where does it come from? And a simple mathematical setup for looking at it is, let's say I describe 3 points, and those 3 points I'm going to label as A, B, and C, respectively. And then I'm going to start by drawing a vector. I'm going to draw here the vector that goes from A, or from C to A, rather. So points from C to A. But I'm going to label that as the vector X, A sub C. In other words, this is the position vector of point A relative to point C. Now let me draw two other vectors. So here is a vector that points from C to B. And that one should be, that's really the position vector of B relative to C. And then I'm going to draw another vector here. Whoops, sort of draw it. It's not perfect. This is the position of A relative to B, or the vector pointing from B to A. But when I see these subscripts, I'm going to label this one as the position of X of A with respect to B. So it's going to be A before B, in other words, in the subscripts there. And it makes sense given the fact that this vector, the C to B pointing vector, is lined up head to tail with the B to A pointing vector. It makes sense that if I say take the vector X, A, B plus the vector X, B, C, that should be equal to the vector X, A, C. And you can see that this vector formula here bears a resemblance in the subscripts to the formula I've written over here. Well, this is a vector that's very simply relating some simple geometry regarding the positions of 3 points. It turns out that if these 3 points all happen to be moving with different velocity vectors, the equation that governs the relationship between the position vectors also governs the relationship between the velocity vectors.